GSM. So if you buy a GSM phone, it is very likely that you will see this the GSM logo on that phone, which says that it is compliant to GSM. But with 3GPP, all the standards were moved on under to 3GPP. When the HC had transferred the responsibility of mobile network standards, and the GSM standard was moved there. The 3G standard is called the UMTS standard. The 4G standard is called the LTE standard, and the 5G standard is also under the 3GPP. At the same time, the ITU, International Telecommunications Union, is also involved in the mobile network standards in terms of defining the usage scenarios. Why we need each of these standards, that's defined by, or the end goals of these standards are defined by ITUT. So the IMT 2000 standard defines 2G, IMT Advanced defines 3G, IMT 2020 defines the 5G standard. If you look at the standards now, and if you look at the times, the 5G standard is still being done, and it is supposed to finish only by 2022. So you should understand this, that usually the standard comes later than the products, because the products guys build the products, and it is the same guys who are building the standards. So usually in all the aspects, the products generally advance the standards, and then finally it gets established. Now we want to understand, why do we need 5G when 4G can give almost everything? What 5G did was specifically defining some of the usage scenarios so that we could make the system better. So what are these key areas? 3GPP defined three main areas for 5G. These are the enhanced mobile broadband. The names are self-explanatory. But you could see that we want to have better mobile broadband. We want URLLC, which is ultra reliable low latency communications, and we want massive machine type communications. So EMBB, URLLC, and MMTC, these are the three major aspects or three major scenarios that we are facing in 5G. What does it mean from a 4G perspective? If you look at the 4G to 5G transition, comparing these two, you could see, and I want to highlight three main points here. One is the latency aspect. I'm sure that many of you use the Ookla app to do the speed test. In the speed test, you will see a latency coming up first. Invariably, if you see your network, the latency will be in the range of 30 to 60 milliseconds. You can try it later on. But the definition for 4G is in the range of 10 milliseconds. We want to bring that latency down to about 1 millisecond with 5G. Theoretically, you are supposed to get around 1 gigabits per second as a peak rate in your 4G system. Whereas for 5G, we want to bring something like 20 gigabits per second. And the connection density, this is not very obvious to you, but the number of connections that is possible in a square kilometer is 100,000 today. And 5G wants to establish in the 1 million connections per square kilometer. So this is the perspective or the fundamental requirements that ITU put forward to 3GPP and say, okay, now you go and build the standard for making these possible. And that's how the standard works. How is it possible to combine impossible things? As in, if you look at these, for massive Internet of Things, what you need is ultra low energy, very low complexity, and very high density. And for enhanced mobile broadband, you need something opposite. You need extra capacity, which is opposite of ultra low complexity. And you need extreme high data rates, which is also opposite of ultra low complexity. It is here we are talking about tens of bits per second, whereas we want user experience 100 plus Mbps and peak rates defined at 20 gigabits per second. And some other aspects, ultra high reliability, low latency. So these are all exclusive, mutually exclusive things. How can we achieve this? These are possible with 5G with something called network slicing. What does it mean? 4G uses, if you think about it, the same pipe. If you want to run your lock from remote, you need to send a command and then it will lock or unlock. That uses probably a few bytes per second connection. You want to run your, say, live cricket, HD live. That needs a few tens of megabits per second. But 4G unfortunately has the same pipe. It cannot change the pipe for the application that we have. What 5G does is it changes the pipe. It uses different types of pipe for different objectives. And this is called network slicing. And this is one of the beautiful concepts that people have come up with. So the core network remains the same, but with the combination of the hardware that we have and the programmability that we have. So in general, people say eventually we should be able to achieve all this with the same type of hardware, even though today we can't achieve this. We can't achieve the same bandwidth and the low latency with the same hardware. We can't achieve low energy, low bandwidth with the same hardware. But eventually, we should be able to program the network to achieve this by providing different types of services as different slices of network. What are the key aspects of 5G that differentiates from 4G? Some of them may be technical, but maybe it's not so much for the final year students. One is the spectrum usage. We always hear about spectrum. What exactly does it mean? To have anything, you need to have a medium. For example, when a mobile phone communicates to a tower, some kind of electromagnetic waves should travel from the phone into the base station. And the path by which it travels is the spectrum. It's like a pipe. So that is why the government sells the spectrum. This is a little bit more theoretical, but you can think about it. There you need a space for some frequency to travel in the air. And if some frequency is already traveling in the air, then somebody else cannot travel in the same frequency. So you need to differentiate, or somebody need to differentiate that there are different spectrums and different people can use different spectra. It is like as you speak, you're all in a class and all of you start speaking together, nobody can listen. But if you had a mechanism that you speak in a specific frequency, your friend could tune into that and listen into it. Then somebody else speaks, you could tune and listen there. So you have a mechanism that everybody can speak, but they are all speaking in different frequencies so that you can listen to it by switching to that frequency. That is the same idea of the spectrum usage here. So the government owns the spectrum in a particular place, and then the government needs to sell a particular bandwidth to a particular carrier, and then the carrier needs to establish the network with that. The phones will cover the entire network, so the phones can carry working across the carriers. So what is the spectrum usage, or the aspect of spectrum usage that is key for 5G is that now there is available spectrum is much wider compared to a 4G network. So you can now use a 20 megahertz spectrum within the available limit that is given to you for one user compared to a 100 megahertz spectrum in 5G. So if you look at this, the 2G were operating in the 700 to 800 meg range here. 3G was moving to probably like 1700 to 1900 spectrum. 4G was mostly in the 1.9 to 2.3 gig spectrum. And now 5G is trying to take as much as possible some of the unused spectrums in many countries. For example, India has the, say, 3 to 6 gigahertz spectrum freely available. And it is very highly likely that this spectrum will be allotted for 5G. So now you have much more space that is available for you to play around, rather than the only allocated spectrums in the previous case. In the frequency range, one aspect. At the same time, it is opening up a huge frequency range in the 25 gig to 56 gig range, which is the FR2 range. So first, it is providing a wider spectrum available. And within that spectrum, individual connectivity is also getting much wider bandwidth. So that is the first aspect. What is the second aspect? is the fact that there is a technique called frequency division duplexing versus time division duplexing. Frequency division duplexing means you use one frequency to reach from the base station to the mobile phone, and another frequency to go from the mobile phone back to the base station. This is a waste of frequency because you're already using up two frequencies. The alternative that is you transmit faster, but for some time you transmit downlink, and for some time you transmit uplink with the same frequency. This requires much more complexity compared to this frequency division duplexing, but it is much more efficient. You are using only one frequency to do it. So that's the other aspect. The third aspect is the modulation capability. So up to 4G, we talked about, okay, if you know wireless communication, most of technologies use something called a quadrature amplitude modulation. Why is it done? To increase or to maximize the channel usage. For example, if you were sending ones and zeros to one place to another, you could combine them. You could make combinations of, say, 4, so it becomes 00011011, and then make a symbol and then send it, so that the other side can get the symbol, and then rather than sending, say, 4, you could rather than sending significantly much more bits, now you can reduce the number of bits and send more information. Like that, you have, say, 8 QAM, 16 stage QAM, 64, and now with the 5G, we are talking about 1024-bit stage QAM. This means that you can put 10 bits into one symbol and send it across. The other side will catch the symbol and then redo it. So like that, we have moved from the lower level of modulation up to much higher levels today in order to take care of higher, or in order to provide higher speeds. So if you think about it, you can easily think that you could probably, why limit at 1024? Why not 2048 or higher? So you might, some of you might have already seen this guy called Shannon. He established a theory called Shannon's limit of channel capacity, which says that you can't infinitely increase the channel capacity by increasing the power. At some time, you will have to deal with the noise. And we are trying to understand what is that noise and how we can reduce it. And that's why every stage of the wireless network, we are trying to reduce the noise and increase the capacity to process. There's also a lot of processing that is done. And now it is possible with the latest digital signal processing and chip technologies, it is possible to process in that level. Go to the next key aspects of 5G. It's called the carrier aggregation. For example, we talked about within one spectrum, there are, for example, the BSNL is allocated, say, 1700 megahertz to 1800 megahertz. And now you can split that spectrum across into maybe 20 meg or 5 meg or whatever you want. Then you can accommodate maybe 20 or 30 customers in that range, right? Now, the carrier aggregation, what it does is it can have multiple carriers connected or multiple base stations connecting to the same mobile phone or end user equipment to provide a higher throughput. This idea is called carrier aggregation. So multiple base stations can provide or operate within the same end user equipment. It is called the UE, user equipment, and provide a higher throughput, which is called the carrier aggregation. It can be within the same band, either contiguous, non-contiguous, intra-band. All these are significantly complex technologies, but now we have technology to do it, or it is possible to do it because of the various capabilities that people have evolved. Then as we move on to the gigahertz range or the tens of gigahertz range, the waves become millimeter waves. As you know, 1 byte of the frequency is the size of the wavelength. And now the wavelength size becomes, in the millimeter range, which means that the technologies or the designs that we have done in the previous designs are not possible. You have to come out with new technologies. But it also gives the capability to transmit higher. That is one thing. But the point here, what we are trying to say is the densification effect. As you see, as the frequency goes up, it reduces the ability to penetrate because the wavelength is much smaller. So it cannot penetrate through mountains, or it cannot even penetrate through huge walls. If you think about it, if you think about the technology here, or if you can look at an analogy, the FM radio stations, FM is much higher frequency compared to the AM radio stations, right? The AM radio stations, you could, it can go to hundreds of kilometers, whereas FM is limited to probably 30, 40, 50 kilometers, because FM's, the wavelengths are much higher compared to the AM stations. Therefore, the millimeter waves cannot penetrate. Therefore, the number of base stations need to be much more. So if you look at the 3G, as we discussed, had much lower frequency range in the 700 to 800 megahertz. So we could have one base station every 10. Oops, sorry. I didn't realize I have gone to 30 minutes. I have a few more slides to cover. Sorry about it. My phone was not giving me the right signal. For 4G, you have much denser coverage, or much denser cells. And 5G, you have much more denser coverage to go through. Or you need much more cells to cover the same distance. The other key aspect is something called massive MIMO. So rather than having a single element of array, now you have a significantly higher number, 64, 128, or 256 elements of arrays, so that you can address individual user with those individual arrays with a technology called it becomes efficient to manage individual customers. Rather than whitewashing everybody with the same signal, you give people what they want. So we can limit it that way. I just also want to cover the base station architectures. Maybe I should take a break here. Do we have another maybe like 10 more minutes we can go through?
Sure, sir, you can.
Okay, great. So if you look at a base station tower, you will not see something called a base. There is a box that is at the bottom of this tower that you usually don't notice. That is where all the baseband signal processing is happening. All the network signals come here. It processes the QAM and related thing that we discussed here, and then it's sent across through this black cable that we see here into the antennas, like the rectangular ones that we hear on the top. You also see this this patram-like thing, which is actually the microwave antenna usually used for the backhaul. So if you look at a block diagram, it looks like that, a baseband unit that is connected closely to the radios in some way. And then this intersection is called the front hall of the network. And then the back portion connecting to the core network is called the back hall. This can be a wired network or a wireless network. Unfortunately, today's world, I also just wanted to introduce you to the people who are building these systems today. There are not many people who can build base stations today. And a few numbers are like this: Ericsson, Nokia, Samsung, Huawei, and Zhongxing Telecom. These are the only people who can build 4G or 5G base stations, unfortunately, today. Even though in India we have C-Dot, there's a company called VNL, there is Tejas Networks. These other three companies also do some smaller forms of this, but they are minuscule. Mostly nobody uses these equipment. But if you see the players, European players, Nokia and Ericsson, Samsung from Korea, Huawei and ZTE from China. These are the guys. Moving on to 5G, what happens in a traditional evolution is they don't change much. They use the same 4G, but change the radio. So if you see the network, it looks like that. They rebrand the base station as a digital unit and then change the radio part first in order to change the 5G. And this is what is going to happen today. So that is why I call it a traditional evolution of network. But there is also a major change that is happening because only 5 people can produce the base stations today. Therefore, there is a technique called VRAN, virtual RAN, whereby people in the, what happens is the 5G core network is built. There is no 4G, it's only 5G base stations. So what happens is the data centers, like using generic servers, are capable of now doing baseband processing capability, and they are connected through high performance Ethernet into the base stations. So initially, this will start in the enterprises where, for example, you have an office, you probably already have a small performing data center within the office. Then you have a controlled network within the office, so that within the office, like the small cells we discussed, we have the capability to have your own 5G network to start with. So this is a drive to combat against the strong hold of the tier 1 base station manufacturers who are the only players in this market today. There are some Indian companies also building the software for the base station market, which is quite interesting. Now we move on to the applications. The first one is the EMBB, the Enhanced Mobile Broadband. So the key application here is the fixed wireless access. As we explained before, if you think about it, today you have a broadband access at home is only because you have a DSL, which is a phone line, or a fiber connection, or a cable connection. All these connections have a problem that somebody has to physically get that connection to you. But what happens with 5G is you don't have a physical connection. You don't need a physical connection. You get 20 gigabits per second to your home with the fixed wireless access capability. And this is one of the first applications that we see with number of 5G deployments in the US is fixed wireless access. The offices are moving to the 5G connectivity and not using the fixed broadband lines because they don't need to have the physical connectivity. New offices can have wireless access. What are the applications with that? The HD, Ultra HD today needs 20 plus Mbps. And if you see, the 4G is barely there. But when we move to 8K, you need something like that. Virtual and augmented reality. Tomorrow you want to go for a picnic, you put a headset on, ask some of your friends to put the headset on. You want to go to Malappuzha Dam? Okay, no problem, let's go to Malappuzha Dam, and you together enjoy as if you were there. That's the virtual reality aspect of 5G. Because of its abundant bandwidth, that becomes possible. Online concerts, even here, when you use Zoom and Google Meet, you can feel that it's not enough yet, even though the technology has progressed so far. Because in general, a few tens of milliseconds already distorts the ability of the ear and the eyes to distinguish sound. So you think about an online concert where people are at different locations and they want to put the instruments together. It's almost impossible today, and that's going to happen with 5G because of the abundance of bandwidth and the delays. This also comes in the next example, but this is one of the examples. Think about going to a cricket match and having the ability to experience the replay at the same time amongst the other 100,000, 1 lakh other users. That's because individually you get the access or you get abundant bandwidth when you are at that place. This is the promise of 5G for the EMBB. The next application is URLLC, the ultra reliable. Ultra reliable always comes with 5 nines or maybe 6. Maybe we can see from Sriram later. Low latency in the range of 1 milliseconds and being secure. The first application definitely being autonomous driving. So the fundamental of autonomous driving is the car needs to know what's happening in the next 10 seconds real time. So that's why the delays of that is now calculated down to 1 milliseconds. The technology that enables to that is the connectivity to everything. It is called the V2X, vehicle-to-vehicle, infrastructure, network, pedestrian, grid, or home. The vehicle-to-network needs to be within 1 millisecond because the network needs to provide real-time information or stream real-time information to the car to say that what's happening inside real-time or in front real-time in 10 seconds. If you know what's happening in 10 seconds, you are safe. That's the idea. Remote surgery, that will take away the or inability of patients to go to a place to have surgery. We are talking about equipment operation. If you were to go to a very dangerous mine and operate an equipment, how can you do it? Today you can't. With 5G, that's what we are trying to do. That you want to go to a dangerous mine and operate an equipment. This is an example from Docomo. They have already demonstrated that this is possible to operate such a big, huge equipment in a dangerous scenario. The last one is the MMTC or the EMTC, the machine type communication, which is the IoT revolution. IoT, you might already know, is the Internet of Things. The best example for Internet of Things is when you walk out of your house, your umbrella will say to you, please take me, it is going to rain today, you have to have me. That's the best example that I can come up with. There is already some technology called narrowband IoT that is existing with the 4.5G systems today. That's enabling multiple of the situations. But in the future, because of the connection densities and the low data rates that are possible, for example, say some of the devices may need only one connection per day, maybe one connection per week in order to provide, or even one connection per month. For example, a smart energy meter. I just need to provide one connection per month to the utility company to say that I have this much of connection. So the EMTC or MMTC enables two technologies. One technology is called the Industry 4.0. So Industry 4.0's future is to provide what we call as the dark factories. Dark factory means you don't need to switch on the light. That means that a factory will work by itself without having to have a light. That's the way that they have termed it. The second aspect is smart cities, the ability to combine various aspects to have or manage assets, resources, and services efficiently. That's the idea of smart cities, and that's possible with the EMTC or the IoT revolution. Maybe at this juncture, I must introduce Sriram. I think you saw Sriram before. He is my colleague, our classmate from 1996 MEC. He has been with Ashok Leyland for some years, then moved on to his own company doing some consultancy work. And then he was with GE for advanced manufacturing aspects. And now he's again, back to us. And he's a wonderful sportsman. He was cricket and hockey team captain of NSS College of Engineering. If you go back and look at some of those photos, you could identify him. So let me introduce Sriram. And we are running a program across the college for which I will just put the poster in. Maybe Sriram, please take the mic.
Thank you, Ulas.
So it's not clear.
Can you hear me now? Better?
No, please drop and come back again.
Okay, give me 1 second. I'm back. Better?
Still not good. I don't know about the others. Neha, can you hear me?
So I think there is some problem with your speaker or something. And the audio is not clear at all.
Any better now?
Yeah, it's audible.
Yeah, fine.
Okay. Thank you so much. Probably this is also one reason why we will be requiring 5G soon. Okay. Thank you, Lars. Thank you, esteemed faculty of our beloved NSS College of Engineering and fellow students. I went back 25 years to my college days. For people who did not know, Professor Nandakumar very briefly told Ullas was a very studious person, but at the same time he was also our mini professor in the hostel. For people like us who are only curious without probably having the sufficient bandwidth in the head, Ullas was our professor in the college as well as in our hostel. And for all the mechanical engineering students, we cannot forget the doping methods, how a capacitor discharge works, how a silicon control rectifier works, etc., without Ullas being there with us to teach us through. And a couple of notes more. It took me back to the college when I heard the prayer. Thank you so much for that. And as the HOD spoke, probably what you should take away from the college is your willingness to be curious. So that's one change which will remain with you forever, and that's what probably we should have when we are at the college. So coming back to the event what we had planned with the help of the Alumni Association, it's called the Ideathon 2020. 2020 probably is not that a great year to be remembered, but probably this will change that. And I did hear that we had a very grand video released in the morning. Thank you, Ashwin and Vishnu, for that. So with this, what we plan to achieve is to spark the ideation process with all the young students at the college. In a year's time, you will be meeting up the category 3 people, as Professor told. You will be taking a job, and in that job, you will meet a very nasty person called the customer. Okay, so this is an opportunity for you to understand your customer needs better. Customer drives the universe, and if you have a wonderful idea, a wonderful product, that will definitely make the customer happy. So this is going to happen in 3 phases. The phase 1 is we have the web link opened today. All of you can put in your ideas into the web link. These links, these are primarily around problem statements like we would like you to do local weather prediction, wild animal detection and alerts, a big challenge in Kerala nowadays. And of course, a topic which is very close to my heart is about the senior citizens' welfare. General topics include assistive technologies. For those who are not familiar with assistive technologies, technologies that help people with learning impairment, people who are physically challenged, mentally not there. So technologies around that. Water and wastewater, I need not tell how important that is for the world. Water is the elixir of the world. Disaster management, very apt topic locally in Kerala, the kind of disasters, natural as well as man-made. And again, as a general public, agriculture and fisheries, without them, mankind cannot survive. And finally, on the power management as well as saving and optimizing. These are the key topics what we have put across. And by 20th of this month, we will be closing the opportunity for you to put in your ideas in these areas. We will take 2 or 3 days to screen the ideas, and by 24th of this month, we will announce potentially 5 groups of people, 5 teams who will then work with our organization, with mentors from the college, to work on your ideas, make it practicable, and then put across to see whether that idea can be made into a viable product or not. Those are 3 or 4 very challenging weeks for the 5 groups of students. And finally, on the 24th of September, we plan to have the final event. We will have some guest speakers, some eminent persons. We are trying to get some of them. And all these 5 groups of students will present their idea to this eminent group. Tough competition, we hope. And then finally, we will have some winners. But what I would like to say is that every person who puts in an idea which can have an impact on socio-economic status of the region is a winner in this competition. So I hope that you will all very actively participate and then be an entrepreneur soon in the coming years. Thank you, Ulas.
Thank you, Sriram sir. We are hopefully looking forward to the ideation event. So,
one more with Neha to finish it off, to say that, sorry, coming back to the topic one more time, maybe we have to set a bit of time for the Q&A, just to say we saw about the evolution of the networks. We talk about the key components, we talk about the key features and the applications. And I should say that even though the topic said revolution, 5G is definitely not going to be a revolution because 4G is already only rolling out now. So you can see a huge overlap between the 4G and 5G, and people don't expect until maybe 2024 or now with this COVID, maybe until 2025 before we should all have 5G with all. So that's the presentation, and then please take over. If you have any questions, whatever mechanism that you want to use, you can, or even I am available offline if you want to speak. Thank you.
Thank you very much, sir, for this fruitful section. Now, if anybody is having any doubts, you can ask right now.
Not only doubts, your comments are also welcome, or clarifications.
If anybody is having any doubts, you can either put it in the chat box or you can turn on the mic.
Yes, please.
Hello, am I audible?
Yes.
Yes.
Sir, as you said that our 5G in the spectrum is going to increase. So is there any effect in humans as this frequency is going to increase?
Yeah, I think it's a very good question. So there are some studies, or mostly there are major studies already being done on the even with the current spectrum that we have, and there are no conclusive answers to that. Every mobile phone needs to go through some permissible level of emission, which is considered to be lower than what is needed for what is possible not to affect the human body. Even with higher spectrums, there are no scientific evidence. If you search internet, you could see that the birds died, this thing happened, that thing happened because of 5G, but nobody has scientifically concluded that 5G with higher frequencies has any impact, because some of these frequencies were already being used. These spectrums were already being used for other applications before. So it is not expected to have any impact on human with the higher spectrum. As an engineer, I may have a different opinion when I put another hat, but yes.
Okay, sir.
Can I also ask a question?
Sure, sir.
Yes, please.
Okay. So, Ullas, just from thinking about manufacturing here, do you think that the current manufacturing techniques are capable, or do they need a change to make 5G ready, either the transmission devices or the mobile phones?
Absolutely yes. Absolutely yes. So all the manufacturing devices need to be digitally transformed in order to be 5G compatible. So that means the functionality may not change, but I'm sure there needs to be the connectivity aspect resolved. There are many issues with that. For example, we say 5G, but what happens if 5G suddenly fails? Those issues are already taken care with the UR LLC kind of network. You make sure that the network issues are resolved. Now the equipment's interface part needs to come up to accept that changes or that interfaces in order to make it 5G compatible. So in order to move to a 5G manufacturing aspect, there needs to be significant change that needs to happen in the way that manufacturing is done today.
And just to add on to any technology limitations to the kind of materials, etc. use, is size such a barrier now?
Can you clarify that, please?
For example, the kind of materials used, will we need better purity of materials, etc.? Fundamental materials.
So if you think about Yeah, if you think about it, for example, many of the systems today probably use some kind of PLC mechanism that is semi-automated or completely automated in a local scenario. So what we are trying to do is only to replace that interface with a network connectivity with some intelligence. There may be artificial intelligence coming to it and so on. So the end product probably don't have much significance or change. If you are asking that question, I don't see that. It's only more towards how the control functions is going to change and how the feedback function is going to change, or the sensing function is going to change from manual or semi-automated to completely networked and intelligent. Is that answering your question?
Yes, Ulas, thanks.
Okay.
Hello, sir.
Yes,
Hello.
please.
Yeah. See, we have seen 5 major players in the 5G who come up with 5G devices or other 5G kind of networks. Right.
Yes.
So why it is always a case like India? None of the Indian companies are there. What is that pulls us back? Is it the economics or economic aspect or technology that we are not capable enough of?
In my opinion, 5G needs significant investment over time. For example, Nokia was established in 1865 and Ericsson was established in 1875. And they have been doing similar network-related work for the entire years. When I said the 5 players, I'm generally only talking about the base station people. So the radio RF design, the base station design, maintaining it across, say, 15, 20 years, all this requires time experience along with the money. So people like Huawei and ZTE and Samsung, they were able to put significantly huge amount of money for shorter time, say like 20 years, to build up that capability. Whereas the other players, we had also players like Motorola who used to build this in some days. They had huge experience in their background. In India, we don't see, except for CDOT, who is a public company player, we don't see a player who is able to build that in that fashion. We don't have that kind of background experience in any companies. We are busy building Infosys and Wipro, who are services companies who can make money immediately. That's like trading. But this is not like that. You need time to be invested in order to make money. And that time investment is huge with the type of, say, designs that we needed. For example, Scandinavian countries and UK have a specific talent for RF design. And that's why, Switzerland and Finland, we haven't heard of this company, but the biggest mobile company is from Finland. They have that, somehow they have that in their bloods. What Huawei and ZTE does is, whenever these big companies closes their campuses in Europe, they go and pick them up. So they have significant talent in that. And in the last 15 years, they have invested massive amount of money into it. And we think locally, we don't have anyone except these public sector companies who can afford to do it. But unfortunately, if we see CDOT, I'm sorry to say it, but it is the progress rate is probably significantly slower compared to somewhere else. Maybe because of the way we manage it, or the way that it is done. It is like that. But it is significant that we were able to build LTE systems. We don't have 5G systems yet with India. They are trying to build it. But we have some kind of LTE systems with CDOT, which usually gets manufactured with somebody like ITI, because in Indian tenders, for the BSNL tenders, you have to have Indian-made equipment. And that's where the significance of VNL and Tejas and those people comes in. So I don't have a complete answer for you, but the fact is we don't have people who have that kind of money or patience to put in, or we don't have that background to establish. Everybody is busy in building software services. As you see, for example, I can ask you the same question. Why is that we don't have a world-known product in India, even if it is in software? We can't say, this is made in India. I don't have like a Microsoft Office or Adobe or something like that. I can't say I have a product that is known across the world. That's because I think the people that we are more towards another type of business than building products.
So I think it is a time that India invests in this domain, like we did in the space.
Yes, because now now this is an opportunity to break the grip of these companies, because now you have the option to build radio alone. And we have very few number of companies who are building it. There is a company called Mavneer, that is the Indian company or Indian based company who builds similar solutions. There are a few other companies who are starting to try to get into this area. So the radio can be independent of the baseband, because the baseband is becoming more software and moving towards the server farm. And then you have a chance that we could put something together. So I absolutely agree with you. Yes, this is a chance to do something like that.
So possibly we need to orient our students to more design rather than writing softwares for TCS, Infosys, and kind of companies, so that there will be a pool of talent there to support the initiatives.
It's a tough question to answer. Even in my class, there are only very few people who are working on the fundamental engineering concepts, right? For example, even for Sriram, I would imagine many of the mechanical engineers have migrated to some kind of software activity already, because that is more money, easy to do, easy to get. Whereas if you stick with the fundamental engineering, it is like the fundamental research. Now we don't see much. It is more of applications around things. So it is a tough question. It is people's choice. But I am trying to also say that there are opportunities. If you really want to do it, you can definitely do it.
Okay, thank you, sir.
Thank you.
Sir, hello.
Yes.
Sir, will there be a relation between Wi-Fi and 5G?
Excellent question. Excellent question. So in many cases, the small cells I talked about, that has an overlap with Wi-Fi. If I have Wi-Fi, then why do I worry about this? The idea was that we could provide an integrated solution. The same box will also provide Wi-Fi, but the same box will also provide cellular connection. The problem with Wi-Fi is Wi-Fi falls into something called sorry, I lost my thoughts here. These are frequency spectrums that don't need license, which is called the unlicensed spectrum. That means there is a limit to which we can use Wi-Fi to. For example, for Wi-Fi, you need to have something like, I think, 100 or 100 milliwatt power. That means the reach of the Wi-Fi is significantly limited. So those applications that needs to have, say, local connectivity can use Wi-Fi. There is a new technology that is coming in called the Wi-Fi 6 that does significantly higher data rates, but still it falls onto the unlicensed spectrum. Unlicensed spectrum means if you switch on a Wi-Fi router, nobody comes behind you. If you try to switch on a frequency that is taken by BSNL, that is sold to BSNL, somebody will come after you. So for application or for systems that are in the unlicensed spectrum, there is limitations. All the cellular technologies, we are looking at significantly larger coverage compared to the licensed spectrum and the connectivity and so on. So they are in general complementary technologies. There are some things that can be used with Wi-Fi better than the cellular technologies, but for some other things, you must have the cellular technology. So 5G and Wi-Fi are not competing technologies; they are complementary technologies.
Okay, sir. Thank you.
Did I answer you, Nitish?
Okay, sir. Thank you.
Okay.
Yeah, I got the clarification.
Okay.
Is there anybody else who have doubts on both section and ideation? You can ask questions.
Yes.
Either you can put it on the chat box or you can turn on the mic. It's a great opportunity that both who's the head of ideation is with us. So please use this opportunity to ask questions.
Yes, absolutely.
Sir, Srihari, you can speak.
So here you can ask.
Hello, sir. I need to ask about the scope of 5G revolution after post-COVID pandemic.
Sorry, can you say again?
Sir, my question is that the scope of 5G revolution after post-COVID pandemic.
Yeah. Yeah. If you see that the only companies who are doing today is the telecom storage related companies.
Yes, sir.
So there is significant importance to communication. For example, rather than presenting it to somebody physically and then appealing to them, now you have to be appealing to somebody over a phone already. So that will come to appealing to somebody over a video call sometime soon. At least in Singapore, most of the major MNCs have dropped their office spaces significantly. And then now they are keeping like 10% of the space to have a floating seating. Nobody has a fixed seat in the offices now. This means that the communication infrastructure and the equipment needs to significantly become better. We already had that experience today, and with the examples that we gave, not only at the office, at your home has to be as good as an enterprise level connectivity. So when you say IT, I would say the infrastructure level needs to significantly improve, and therefore there will be a significant growth in the 5G technologies, not only on the base station and the data rates level, but also in every aspect of the network. More connectivity to the back end, because more people are working from home. Everybody needs to access higher content back, from or bigger content back from a central place. So the significance of that is huge. And many of such companies, like I know personally, Dell EMC had a significant quarter last year. Microsoft is trying to build, they call it, it is unfortunate, but they call it COVID opportunity. The COVID opportunity is like 10% of their business now. That means increasing Azure or similar businesses. Everybody needs to have some cloud space today. So your question is extremely valid, and the answer is the importance and significance is significant. Any others who wants to comment, please go ahead. But this is my opinion.
Sir, one more question I have.
Please.
Yes, sir. Since economies are falling down, what are the challenges that new entrepreneurs as well as multinational companies would undergo if they have to invest a lot of money in this 5G revolution, and how we could be prepared for that?
Okay, I think that is also a very high philosophical question, a little bit philosophical, I would think. I will take it in two steps. The first step is technologies. Even though the economy is down, there is no shortage of funds to innovate. That I can, guarantee. I can tell you that that's the situation, because a lot of people have pulled out their monies from other investment instruments and looking for opportunities to invest. So that is one way to look at it. So for innovation, the funding process is not limited for now. The second aspect is key, that how do the infrastructure rollout will happen in this context. So this I can also look at it in two ways. One, in a lot of countries, the infrastructure has an impact on or by the government as well. That means the fundamental infrastructure companies are mostly funded by the government. So in order to improve the economy, these companies will definitely push to improve the rollout as fast as they can. Because many of the companies, for example, if you look at BSNL, they are not doing it for money. They are doing it for the thing that, there needs to be that service and the impact needs to be there. If you look at the cases, if you see, the way that India works, in many cases, if everything fails, BSNL will not fail. Because they build their networks from very fundamental aspects, whereas many other private companies do it with other service providers. They will also outsource everything. The network doesn't belong to them. So this aspect will definitely help to have the infrastructure on. And I personally consult some of the telecommunication companies, and I can see that the drive is more, not less. The equipment is moving more, not less, because they want to have this come faster so that people can work remotely faster. There may be some companies who may be affected by their cash flows or plans to roll out it later. But I would think that in general, the revenues are not going to get affected by this. The revenues will continue to improve because people will have to spend. For example, if I had to start an outdoor activity park, I will think twice. But this is a guaranteed business that I am getting into. And a lot of people will have already found their ways to invest onto these plans. So I don't see a big effect or impact even with this bad times. That's my take on it.
Yes, sir. But they I agree with the fact that many multinational corporations are capable of being investing in 5G revolution still now, because many of the multinational companies are having profit even during this pandemic. But what we can expect is that many startups won't have the fund after the pandemic, and would it not create a monopoly of the multinational corporates in the 5G revolution?
So that is what we were talking about, Srihari. It is already a monopoly. Not many people can play in the 5G, at least in the base station game today. Not many people can.
Yes, sir.
You're right. Depending on the segment that we look at, this may be a point. But that's the fact that it is only multinationals, and especially these 5 people who are playing today. We don't see anybody else doing a base station with 5G network. As you could search for the internet and see 5G deployments. You'll only see these 5 people.
Yes, sir.
So I agree with you.
Yes, sir. But the main thing that government is create these new technologies by ourselves. That's why we are always wanting startups. But even though entrepreneurs, that new entrepreneurs with different startups are not getting their benefit in this race. So what do you think about that? How can we as an entrepreneur develop our skills to this challenge?
This is also, I don't have a very straightforward answer to this, Srihari, because the entrepreneur mindset is not very straightforward. It is like a gambling, right? In many cases, for the entrepreneur, you need to have a catchy product that will provide multiple levels of profit in short time.
Yes.
So that is the external entrepreneur's perspective on it. So the best way to approach it is to look at entrepreneurial funds that are not looking at significant profits. For example, I think last week I heard that this Maker Village concept was there. So there are government projects that are available that may have other red tapes associated with it, but their prime objective is not to, make money out of you, but to help you. So the only way to, look at in that direction is to see that such funds can be tapped at first in order to get to the first level. But I can tell you, if the idea and implementation is top class, you will definitely find an investor. I have no doubt about it.
Yes, sir.
Thank you.
Thank you, sir.
Hello, sir.
Yes.
So myself, Nitin, I have a small doubt about the ideation. So we have an idea and it incorporates a small part of a patented work in it. Can we still register the idea? And also, it's a question in general. How can we market the patent, an idea which has a patent content in it? And basically, how to safely incorporate a patent content or a product to a market? Because even safety pin is patented, right? So if we want to incorporate those kind of steps, then what are the things we have to keep in our mind?
Ulla, should I attempt?
Yeah, please.
Okay, so right now the challenges and the problems what you listed down, if you have an original idea, that can be posted in. We are not expecting that you have already an element or an IP content and then present it. We will try to protect your IP. We are not going to take out the IP from your idea and then take it away. However, we will help in whatever way we can to help you to protect your IP and then take it forward. But it is our advice that you provide original ideas which do not have any current IP content inside that.
Oh, okay, sir. But I'm asking whether every idea has to, even in every idea, there will be a small amount of patent work, which is non-avoidable. So, is it okay to market it?
Yeah. If it is getting shortlisted, we will help you to nurture the idea and then potentially help you to realize the idea, maybe even up to a patent. We are not taught yet through that process. Right now, our objective is to get maximum ideas in and then help you to make a commercially viable product. We are
one point to clarify is also, Nitin, that we cannot generally say that every idea has a patent. There could be many things that is not patentable. The general things are not patentable.
If there is a patent on an idea and we have an improved version of that idea, then we can file for a patent for it. Was it audible, sir?
Yeah, you can always patent for it. I mean, I can't get the crux of the question, Nitin. What do you mean?
What do I mean is, sir, as I said like earlier, I have an idea and it incorporates a small amount of help from another vendor.
Okay.
So, can I market it?
Yes, and you can keep the patent. You should file the patent first, and then you can approach somebody and say that either you want to sell the patent or you want to have the royalty to the patent, or you can help to build it, but they need to manufacture it. One of those ways you can always do it.
Okay, sir.
Is that answering your question?
Okay, sir.
Okay, yeah. Please talk to us separately if you need to, Nitin. We can give you clarification otherwise. There is also a question from Darshan that says the mobile data charges in India are very low when compared to the countries in the West. Do you think that it will still remain same even after rollout of 5G? So in my personal opinion, the cellular rates of India are not sustainable, right? We can see that many companies are going out of the India market because they can't catch up with that pricing that they have today. So they do it in different techniques. This is what I was telling before. Many of the companies don't have their own network. They will outsource to the equipment vendor. For example, I know Airtel outsources the equipment vendor like Nokia or Ericsson to build and maintain their network. Airtel will only build it. So in such companies, it is not, they find different ways to do it, but it reaches an end point where you can't sustain that model. So in my opinion, one, the 5G rollout will be much delayed because you need to get back all the money that you have invested in 4G, so that a revolution is going to happen. It is going to be an evolution. And secondly, no, I think it will be higher than what we have today, because there is a huge investment. There is a lot of things that needs to be ripped off and put new, especially the back end part of it, in order to provide the full experience of 5G. So it won't be cheaper than what we have, is my opinion on it.
Okay, sir. Due to the time limit, I think we can wind up. So thank you for this informative section that you guys have given to us. This has surely helped us all learn more on 5G and the program ideation. Thank all the participants for their cooperation. Now I invite Rahul, Secretary of ELASCTA, for vote of thanks. Over to you, Rahul.
Thank you, Neha. Respected speakers, faculty, colleagues, and all the participants. It's my privilege to have been asked to propose a vote of thanks, and I, on behalf of the entire team of ELASCTA and IET, would like to call it a fraternity of techies here together. And on my own behalf, extend a very hearty vote of thanks to our speakers, Mr. Ullas Kumar and Mr. Sriram Harihare, for gracing their opinions on the topic and their valuable time for us here. Thank you, sir. And I thank all the participants for showing their overwhelming response. And I request all the participants to register their feedback through a Google form posted in the chat box. Thank you all.
Yes, Sriram and I would like to also give great really appreciation for conducting this session. We really thank you. And we want to leave you with these words of Sir Isaac Newton, that he says if he has seen anything further, it's by standing on the shoulders of the giants. So we also wanted to tell you that the giants are already standing there. Please climb on top of them and look far ahead. You have the opportunity to look ahead with all the knowledge that you get from the theories that you study from these, giants like what Isaac Newton had, and all the very best.
Thank you, sir. Thanks a lot for giving our first section. It's a great opportunity to meet you guys.
Thank you, sir. Thank you, Mr. Ullas, Sriram. Thank you for spending your time over here.
Thank you, sir.
Thank you.
Thank you, sir. Both of you.
Hopefully, we could have even continue our interaction after the ideathon is completed and take it further.
Sure, yes. Yeah, we can also get some speakers for you who are experts in their fields.
Yeah.
Or take some related fields accordingly later on in the coming months or years. So
okay. Thank you.
Thank you, sir.
Really great. Okay, thank you. Bye then. Bye.
Yeah.
Bye.
Yeah. Thank you.